When we begin to learn about linear systems. A system means we're going to have more than one equation. So a solution of a system of linear equation means that that one ordered pair, so one value for x and one value for y, will satisfy both of the equations. You can pause and read through this screen if you need to. So it says use the graph to solve the system of linear equations. So we're given two different equations, 3x plus 2y equals 4, and also the equation negative x plus 3y equals negative 5. If we go ahead and graph those, it said that they already graphed them, we can see they have an intersecting point right here. That intersecting point is at 2, negative 1. I went over 2 on my x-axis and I went down 1, so negative 1 on my y-axis. So that means that that coordinate point will satisfy both of those equations. Now I can check that by substituting it in. So if I say 3 times 2, substituting that x value, plus 2 times a negative 1, we want to see, is that true? Does that equal 4? So we would have 6 minus 2, and that does equal 4. Let's try it for the other equation. So I have a negative x, so I have negative 2 plus 3 times a negative 1, the y value. And does that equal negative 5? So I would have negative 2 minus 3, and yes, that does equal negative 5. So you can see that by looking at the graph and finding the intersecting point, we have found the solution, or what will satisfy both of those equations. So to solve a linear equation using graph and check, we write each equation in a form that is easy to graph. Remember, you have learned 3 different ways of graphing. You have learned slope-intercept, and you have also used quick graph. The third one we will learn is going to be how to put it on a graphing calculator, which we will be doing later in class. So you pick which way is the easiest way to graph. Then you graph both equations on the same coordinate plane, and you look at where that point of intersection is. You can then check that, as we just did, algebraically by substituting each equation into each equation of the original linear system. So let's see what this screen's got for us. First of all, write in a graphing equation. Graph these equations. So let's go ahead. I'm sorry, I bet you we should put one of these on the board first and then talk about the steps. So, and let me just check and see what my example, yes. Let's go ahead and do this for example 2. So, example 2 is going to be the equations x, I'm going to write these, x plus 2y, oh no, x plus y equals negative 2. And we also have 2x minus 3y equals negative 9. I'm going to put these into our most common. I'm going to put these into slope-intercept. So for this one, I need to get rid of my x. And so my slope-intercept form will be y is equal to negative x plus 2. This next one, I'm going to get rid of my 2x. So I'm going to have negative 3y is equal to negative 2x. Whoa, that got a little fancy. Negative 2x minus 9. No, I can't see my minus 9 there. And then I need to divide everything by a negative 3. and I would get y, oh, come on, y is equal to, negative 2 divided by negative 3 would be a positive 2/3. So I'd have 2/3 x, and then a negative 9 divided by a negative 3 would be a positive 3. Okay, so the step for solving these equations is to graph them and look for the intersecting point. And then it says finally to check. So y equals negative 2 is my y-intercept. And so then I'm going, it's a negative slope. I can actually go up 1 and then to the left 1, or I could go down 1 and to the right 1, and there is our slope. So this line here is for this equation. This equation, y equals 2/3 x plus 3, we have our y-intercept at 3, and my slope is going to be a 2/3. So it's a positive slope. You see it's going positively. I can go up 2 and over 3, 1, 2, 3, and this would be my other point. They kind of cut that graph off a little bit. I could also do a negative 2 over negative 3, because that would still be a positive slope. So if I went down 2 and negative 3, here would also be a point that I could draw my line. Now this point in particular happens to be our intersecting point. So our intersecting point appears to be at negative 3. I'm going to put this here. It's going to be at negative 3, and then it's up 1 on the y. It's negative 3, 1. So our last step is that we need to be checking that intersecting point and see if it is true for both statements. So I'm going to look at the first one here. I'm going to substitute, and I'm going to go back to my original statements. So I'm going to substitute in the negative 3 and the 1 for the x and the y. So my original statement here, they'll let me write on there. There we go. Is going to be negative 3 plus my y is 1. Does that equal negative 2? And that does. Now I'm going to look at my other, let's give it a green one here. My other statement, my other equation, 2x minus 3y equals negative 9. So let's go ahead and see if that is true as well. So it would be 2 times a negative 3 minus 3 times 1, and it should be true that that equals a negative 9. So let's go ahead and check that out. 2 times negative 3 would be negative 6. Negative 3 times 1 would be negative 3, and that also makes a true statement. Negative 6 minus 3 equals negative 9. So that is how we prove that that is a solution for that system, those linear systems. It works for both of the equations, that solution. So our next one says we're going to model a real life problem. So the internet in the fall, the math club and science club each created an internet site. You are the webmaster for both sites. It is now January and you are comparing the number of times each site is visited each day. So there are currently 400 daily visits, and the visits are increasing at a rate of 25 daily visits per month. So for the science club, we could say the daily visits equals the current visits to the science site plus the monthly increase for the number of months. The math site, we have a similar one here. So let's go ahead and fill in the data that we know here. So for science, we have that, let's get back to a better color though. So for, well, science, we can do green for science, not red, green. So for science, we have that we know there are 400 daily visits. That's our constant term. And that's going to equal the, we'll go ahead and we'll say the current visits, which are going to be, whoops, I'm sorry. Let's, let me see here. Whoops. So in the fall, the Math Club and the Science Club each created an internet site. And you're going to be the webmaster for both those sites. And it is now January, and you are comparing the number of times each site is visited. So we know that the Science Club, there are 400 daily visits, and they're increasing at a rate of 25 daily visits per month. Okay? Now the math, we have that there are 200 daily visits, but it's increasing at a rate of 50 daily visits per month. So our problem is, or what we're going to try to figure out for a system, a linear system here, is we want to predict when the number of visits of the two sites will be the same. Now, this is from your textbook. I'm going to just change something just slightly because our information, we have rates and we have constant terms. So we know when we have rates and constant terms, we can write that in slope-intercept form. So I'm going to go ahead and I'm going to write my science one as y equals, and my rate is going to be 25. Oh my goodness, I keep getting I don't think you can see that on the recording, but my keyboard keeps popping up on my iPad. So my rate is 25 times, so we'll just use t. Actually, no, I'm going to use x so that you can follow that this is slope-intercept form. So 25x, because that's going to be my rate as my slope, plus my constant, which is 400. Because remember, we have to go ahead and we need to graph these to see their intersecting point to find when the numbers are going to be the same. So now I'll move to my math, and I'm going to write that one in slope-intercept form. So y equals, my slope is going to be my rate, 50x, plus my constant, and my constant was 200. So now I have my two equations, and I'm going to graph them to see when they are going to intersect. So I have them graphed here now because I have them in slope-intercept form, and I find an intersecting point right here. That intersecting point is at 8 for my x value, and then my y value is at 600. So if the monthly increases continue at the same rate, the sites will have the same number of visits in the 8th month after January, which is September, and they will be at 600 visits. That's the way I can interpret that data, that system of linear equations that gives me the 8-month 600 visits. Okay, 8 month because that's the x-axis, 600 visits because that's the y-axis. And that concludes lesson 7.1.